All right, so today we're going to talk about the next transformation, which is going to be rotations. Rotation, again, is an isometry, and isometry means that your pre-image and image are going to be congruent. But we need to be able to rotate figures, okay? All right, so a rotation is a transformation in which a figure is turned about a fixed point. And so the sort of shortcut word for a rotation is a turn. So we're going to turn it. We can turn it clockwise or counterclockwise. The center of rotation is the point around which we'll rotate the figure. And the angle of rotation is how far we're going to turn it. At what angle are we going to turn it? And the angle is created by rays from the center of rotation. Okay? All right, so if we want to rotate, and this is going to be hard to show, so I'm going to try and talk you through it. We went through it in class. But as a review, if I wanted to turn this shape 120 degrees about P, and make it a clockwise rotation, your notes say clockwise rotation. That means that we're going to rotate like rotate this triangle around like a clock, the way a clock goes, right? So it's going to go this way. Now, if we want to rotate it 120 degrees, then what we need to do is we need to create the degree first, and then maintain distance between A prime and P. Well, maintain distance, and here's what I mean. I want to make a 120 degree angle at P so that A is on one side of the angle and A prime is on the other side. So to make sure that A is on one side of the angle, I'm going to draw a ray, or I'm going to draw a segment from A to P. And then with my protractor, right, and I'm going to draw a protractor on here pretty quickly, okay? I would place it this way so that the arrow or the middle of the protractor is here. And I would want to push this down to where it lined up, the straight line would line up on that segment. So let's maybe draw it that way. So your protractor would sit like this so that the arrow or the middle of the protractor is right there on P. And then we're going to measure 120 degrees. 120 degrees is obtuse, so you'd want to go all the way, go find the 120 degrees that pushes you all the way over here. And that's going to be your other side. So maybe here. And this is just a guess. This probably is not perfect. So then now we would have this angle. Okay? So this is 120 degrees. A is on one side of the angle. Now we want to put A prime on the other side, but we want to make sure that A prime is the same distance away from P that A is away from P. So we grab our compass. We put our point here on P. We put our pencil here on A, and we arc. And this is where you would put A prime. Okay? At which point I would erase all of this, leaving A prime there. And do the same thing for C. Make a side here for an angle. Put your protractor down so that you're rotating this way. Make a 120 degree angle with your protractor. And then compass, needle goes here, pencil goes here on C, rotate it around, and so C prime would end up here. You erase all these marks. Draw a line at B, measure 120 degrees, which might be, I don't know, this is not going to be exact. Then needle here, compass needle here, pencil here on B, and arc it, and maybe B ends up right there. This is terrible. But again, this is, I'm not measuring this out, so B prime should end up someplace. See, this is C prime. B prime would end up someplace out here, probably. Okay? And so you would have rotated it. Okay? And showing this by hand is very difficult without actually having a protractor and a compass. So if you need some help with this, make sure you come find me, and I'll walk you through it with the actual tools. Okay? And so there are some steps here. Draw a segment from A to P, and so your segment would look like that. Or I could just use the notes. Look at this. I should have kept going. Right? Now, this one's going counterclockwise. And it's an interesting thing to note here. If you're not specified which way to go, counterclockwise is sort of the default. So you go against the clock, so this way. So since you're going against the clock, you'd make your segment from A to P, and then place your protractor so that it opens this way. And then measure your 120 degrees, and you see that's what happened there. And then take a compass and draw A prime so that the distance between A and P and A prime and P are the same. Compass would be the best way to do it. You could certainly grab a ruler and just measure it, but a compass is more accurate. Okay? And then you do the same thing for the other two vertices. And so again, if you were to rotate that same triangle counterclockwise 120 degrees, that's what it would look like. Okay? Now you can try the 50-degree rotation for triangle DEF here. And again, let's go counterclockwise. Since it doesn't specify, we'll go counterclockwise. I think your notes say clockwise, but let's go counterclockwise. Okay? So hopefully you've gotten that rotation done, and it should look something like this. So you've moved from here down to here. Okay? Now, there are rules, just like there are reflection rules when you're reflecting in certain lines, x-axis, y-axis, y equals x, y equals negative x. There are rules for certain rotations, but they're only, like I said, they're only certain ones. They're very specific. You have to be rotating about the origin in the coordinate plane, and you have to be going counterclockwise. Okay? So, origin, this has to be your center of rotation, and you have to be rotating counterclockwise. If that's the case, then there are rules for a 90-degree rotation, a 180, and a 270. If any of these things do not hold up, if any of these things change, you cannot do these rules. So if you're rotating clockwise, the rules are out. If you're rotating about a different point besides the origin, rules are out. And if you're rotating in any other degree besides 90, 180, and 270, rules are out. You have to go back to doing it manually. But there are some rules. If you're rotating counterclockwise about the origin and you're rotating 90 degrees, then what you do is you flip-flop your coordinates for your vertices and change the sign on your new x. If you rotate 180 degrees, you keep the coordinates the same order, x stays x, y stays y, but you change the sign. And if you rotate 270 degrees, you flip-flop the x and the y, and you change the sign on your new y. Okay? So let's check it out. How do we use these? So we have coordinates 3, 1, 5, 1, 5, negative 3, and 2, negative 1. If we were to graph that, we'd go 3, 1, 5, 1, 5, negative 3, and 2, negative 1. Okay? And we want to rotate that. Well, our new point, our image, R prime, if we rotate 270 degrees counterclockwise, then we're supposed to flip-flop the x and y and change the sign on y. So R prime would become 1, negative 3. Flip-flop and change the sign on your new y. S prime would become 1, negative 5. T prime would become negative 3, negative 5. And U prime would become negative 1, comma, negative 2. So that if we plotted the new points, 1, comma, negative 3 for r prime. Let's do a different color. S prime is 1, comma, negative 5. T prime is negative 3, negative 5. And U prime is negative 1, negative 2. We'd rotate to there. And it's rotating 270 degrees this way. Okay? Which, oh, by the way, is the same thing as rotating 90 degrees clockwise. So there, you could use these rules, but they get kind of confusing. So just a heads up. Okay? Now, if we were to, don't want to show you that. In your notes, you have to graph triangle JKL and rotate the triangle 90 degrees about the origin. So find your rules, use your rules, and come up with your new vertices. Take a second and try that. Stop the video and start it back up when you're done. Okay, new points should be this. Okay, you're supposed to flip-flop the x and the y and change the sign on the new x, but you can't change the sign on 0. So that's why J prime is 0, comma 3, L prime is 0, comma 6, and then K prime we flip-flop 3 and 4, change the sign on the new x, get negative 3, comma 4. Your new shape should sit like this. So we've rotated 90 degrees counterclockwise. Okay? Now, like I said, rotation is an isometry, which means that the image and the pre-image are congruent. So in a situation like this, where you're doing a standardized problem, they might ask you to find y. Well, you have to match up these sides, right? So you have to imagine rotating this shape to here. And when you do, this piece and this piece are going to be the same side. So we can set 5y equal to 3x plus 1. But then you'd also have to understand that this side and this side are the same, so 2x would be equal to 6. Divide by 2 on this first one, and x is 3, because we can solve that one. And if x is 3, then I can plug 3 in to this x right here. So we get 5y equals, 3 times 3 is 9. Get 5y equals 10. Divide by 5, and y is 2. And so your answer here is B. Okay? Simple as that. Now you try. Try to match up the sides here and find R. Okay, and there you go. Again, match up the sides. You get 2s and 12 are the same side, 2s plus 3 and 3r are the same side. And so R would end up being 5. Okay? Issues there, make sure you come find me, especially if you need some help with the manual, the compass and protractor rotation. I'll be more than happy to walk you through how to do that. Okay? Homework's out in Canvas. Make sure you get that done by next time.